Hello students, welcome to ASCII Math. Today we will learn how to form a differential equation if the general solution or a solution is given for that differential equation. So as you know, the solution is in a function format, and if in that function there are one constant or one parameter, then we will differentiate once, and if that equation contains two constants, then we will differentiate it twice. Similarly, if there is three constants, then we have to differentiate three times. Since we have learned to differentiate twice, so we will have only two constants at most here. And today my voice might be listening different to you since I am having this infection in my throat, so that's why my voice might sound a little different to you today. So let us see some questions and learn how to form differential equation. Question 1. Here form the differential equation of the family of concentric circles, that is x square plus y square equals to a square. And here a is a parameter which is greater than 0. So this is actually a solution of the differential equation which we are going to form here. So since this equation contains one parameter or one constant, that is a, so we will differentiate this equation one time. So here the given function is x square plus y square equals to a square. So differentiating both sides with respect to x, we will have 2x plus 2y into dy over dx equals to, since a is constant, so derivative of a square will be 0. So this implies taking out 2 common, then we will have x plus y over dy over dx equals to 0. So dividing both sides by 2, x plus y dy over dx equals to 0. And this equation is the required differential equation. Since the parameter, that is a, has been removed completely, and this equation contains the first order derivative also. So that's why this is the differential equation which question was asking to form. Question 2. Form the differential equation of the family of curves a equals to a cos nt plus b sin nt, where a and b are arbitrary constant. Since this equation, that is x equals to a cos nt plus b sin nt, contains two arbitrary constants, that means we have to differentiate this equation twice. And here we have to note that this is a function in t. Here x is a function of t. So differentiating both sides with respect to t, we will have ddt of x, that is dx over dt, equals to a is constant. Ddt of cos nt is minus n sin nt plus b. Ddt of sin nt is n cos nt. So this implies dx over dt equals to a minus a into n sin of nt plus b into n cos of nt. Now again differentiating both sides with respect to t, we will have d2x over dt2 equals to minus an is constant. Ddt of sin nt is n cos nt plus bn is constant. Ddt of cos nt is minus n sin nt. So d2x over dt2 equals to minus an square cos of nt minus bn square sin of nt. Now let us take out minus n square from these two terms. Then we will have a cos nt plus b sin nt. And if you look from equation 1, this a cos nt plus b sin nt from equation 1 is x. So replacing these with x, we will have minus n square x. And this is the value of d2x over dt2. So this implies d2x over dt2 plus n square x equals to 0. This is the required differential equation which was asked in the question. And if you notice that, then this equation is free from a and b. So make sure your differential equation should not contain any arbitrary constants. Question 3. Form the differential equation of the family of circles touching the y-axis at the origin. See, sometimes the question will give you function or the solution or the equation of the curves. But sometimes the question will indirectly give the equation of the curve. Just like here in this question, they are asking to form the differential equation of the family of circles. So for that, we should know the equation of some shapes like circles, ellipse, parabola, hyperbola, etc. or straight line. So they are saying the equation of family of circles that is touching the y-axis at the origin. So first let us see this graphically, then we will have, suppose these are the coordinate axes, and let this be the required circle that is touching the y-axis at the origin. So the center of the circle will lie somewhere over here, and let the coordinate of this point, that is the center of the circle, be a comma 0, and of course the radius will be a, because the radius is the distance of this 2 points, that is from origin to that point, that is a. So in general, the equation of a circle is given by x minus a whole square plus y minus b whole square equals to radius square. But since the value of b is 0 here, that is the ordinate, so putting the value of b as 0, and the radius is a, so we will write a square. Hence the equation will be, opening this using a minus b whole square, we will have x square minus 2ax plus a square plus y minus 0 is y square equals to a square. So here a square and a square got cancelled. So we will left with x square minus 2ax plus y square equals to 0. So this is the equation of the circle which touches the y-axis. And this equation represents the family of all circles, because as you can see here, this a is the parameter which is the radius of the circle. So the size of the circle depends on this radius. And since this equation contains one parameter, that is a, so we will differentiate this particular equation one time to obtain the differential equation. So differentiating both sides with respect to x, we will have 2x minus 2a plus 2y dy over dx equals to 0. Now since my aim is to get rid of a, for that let us suppose this as equation 1. So taking 2 common, we will have x minus a plus y into dy over dx equals to 0. Dividing both sides by 2, we will have x minus a plus y dy over dx equals to 0. So from here, the value of a equals to x plus y dy over dx, and let this be equation 2. Now we will substitute this value of a in equation 1. On doing so, we will get rid of a. So let us put the value from equation 2 in equation 1. Then we will have x square minus 2 into a, and since a is x plus y into dy over dx into x plus y square equals to 0. Hence my required differential equation will be x square minus 2x square multiplying, there is x also here, minus 2xy dy over dx plus y square equals to 0. Simplifying these two terms, we will have minus x square minus 2xy dy over dx plus y square equals to 0. rearranging the terms, writing y square at first, minus x square minus 2xy dy over dx equals to 0. So this is the required differential equation, as this equation contains no arbitrary constant. Question 4. Form the differential equation of the family of parabolas having vertex at the origin and axis along positive y-axis. So let this be our coordinate axis, and let this be the graph for this parabola. Since the axis is positive y-axis, so our parabola looks like this. And the equation of this particular parabola is written as x squared equals to 4by, where this point B is, the coordinate of the focus, that is 0, b, and B is the focal length. Anyway, we got the equation of parabola, that is x squared equals to 4by, and since this equation contains one parameter, that is b, so we will differentiate this equation one time. So differentiating both sides with respect to x, we will have 2x equals to 4b is constant, the derivative of y is dy over dx. So here 2 and this 4 got cancelled. So x equals to 2 into b dy over dx. Now since my aim is to get rid of this constant b, so from here the value of b can be written as b equals to x divided by 2 into dy over dx. So let this be equation 2, and let us put this value of b in equation 1 here. On doing so, we will get rid of b. So putting the value of b in equation 1, we will have x squared equals to 4 into the value of b is x by 2 into dy over dx into y. So here 2 1 the 2, 2 times 2 is 4, and on cross multiplying we will get x squared into dy over dx equals to 2xy. Here we can cancel x and this x also, hence the required differential equation is x into dy over dx equals to 2y, since this is free from parameter. Form the differential equation of the family of ellipses having foci on the y-axis and center at origin. So let us draw our coordinate axis. It has the major axis on y. So the equation of this kind of ellipse is written as x squared by b squared plus y squared by a squared equals to 1, where a and b are parameters, and in the ellipse it is actually the coordinate of the vertices, that is b comma 0 here, and this point is minus b comma 0. The coordinate of this particular vertex is 0 comma a, and here at down it is 0 comma minus a. Now since this equation contains two parameters, so we will differentiate twice and get rid of a and b. So differentiating both sides with respect to x, we will have 2x over b square plus 2y over a square into dy over dx, and the derivative of 1 is 0. Let us take out 2 common from here, then we will have x by b square plus y by a square into dy over dx equals to 0. Dividing both sides by 2, we will have x by b square plus y by a square into dy over dx equals to 0, and let this be my equation 2. Now again let us differentiate both sides with respect to x, then 1 by b square is constant and ddx of x is 1, so we will have 1 by b square only here, plus here 1 by a square is constant, and since there are two functions getting multiplied, that is y into dy over dx, so for that we will apply the product rule. So keeping y and differentiating dy over dx, we will have d2y over dx2, plus keeping dy over dx and differentiating y, we will get dy over dx only equals to 0. So let us try to write this equation in terms of 1 by b square. So 1 by b square will be minus 1 by a square into y into d2y over dx2 plus dy over dx whole square. Now let us put this value of 1 by b square here in equation 2. On doing so, we will get rid of b. So put the value from 3 in equation 2. Then since there is x into 1 by b square, so we will have minus x by a square, putting the value of 1 by b square into y into d2y over dx2 plus dy over dx whole square, and we have plus y by a square into dy over dx plus y by a square into dy over dx equals to 0. Now to get rid of a square, we will take out minus 1 by a square plus 1 by a square from these two terms, then minus 1 by a square taking common, then we will have x, let us open the bracket there, then xy d2y over dx2 plus x into dy over dx whole square, and from this another term we will have y into dy over dx equals to 0. Now let us take this minus 1 by a square to other side, so 0 over that number will be 0, and hence we will have our differential equation, that is x into y d2y over dx2 plus x into dy over dx whole square plus y into dy over dx equals to 0. So this much in this video, we learned how to form a differential equation if the solution or the equation of the curves are given. In the next video, we will learn how to solve the given differential equation. That means we have to find the solution or the equation of the curves. So till then, keep practicing. Bye bye. See you in next video.